Today's video is the final video in my series where I wire up my new house for home networking, whole home audio and various other smart home services. In my previous videos you'll have seen where I talked about my plans, I ran all the cables, and then in my last video I went around the house and terminated all the faceplates and jacks in all of the rooms, or at least most of them. Since then I've done a fair bit of additional work. I've finished terminating off a few in the other rooms that I hadn't got around to, and I've also terminated all the keystone jacks at the rack. So in this video what we'll be doing is we'll be getting the rack fully set up. We'll be installing all the patch panels, getting all the keystone jacks installed, getting all the speaker cables terminated, and then finally getting all the active networking equipment, switches, firewalls, servers, all that sort of stuff into the rack and get it all up and running. So yeah, since my previous video I've terminated all those ports around the rooms, and as you can see here I've also terminated all the network runs into keystone jacks. And I massively underestimated how much effort this would be. I was just, when I was pulling the cables, and I just kept pulling more cables in, thinking, oh, I'll just run even more cables to this room. Oh, it won't be too much effort to pull 4 runs into here, I'll just do that. And then when it came to terminating them, I had about 40 odd network runs to terminate, which meant I had to terminate 80 of these keystone jacks, which I timed, and they took maybe 6 to 7 minutes to terminate each of these keystone jacks. So when you do the maths there, that's a lot of time just standing terminating keystone jacks. Both crouching down behind desks and also standing in this freezing cold garage trying to get these on. When it's so cold I found myself even having to use a hairdryer to warm the cables up to get them to bend nicely into the jacks. So yeah, that was an absolute nightmare. I definitely underestimated how much effort that would be. But yeah, we have all the keystone jacks all now terminated, and I've labelled them all up with the same designation as all the ports in all the rooms. So I can easily get these into the patch panels and get them all connected. So yeah, here we have a closer look inside the rack. We can see we've got all the jacks on, so we can see we've got them all labelled like that. Same designation as in all the rooms. Most of these are obviously the shielded Cat 6A keystones that I'm using. Some of these are just Cat 6 runs, like these ones here, so these are just into standard Cat 6 keystones. And then there's a few runs I haven't terminated yet. These purple ones are the cables that I ran to behind a couple of light switches for future smart switching, so these aren't obviously connected yet. And then these black ones are for cameras. Now this is something I forgot to mention in the previous video, and a few people asked, wait, aren't you running cables for cameras? I am, I just forgot to mention them. So these two are currently coiled up above the floor in the back bedroom. Ultimately when I get the cameras I'll then be putting them back under the floor, drilling through the wall and trying to feed them out the wall, but I'm just keeping them inside for now rather than drilling holes in the outside walls and then leaving cables hanging out of them for weeks until I get the cameras. And then there's a couple more camera cables I'm going to run in, but those will run in trunking or in conduit inside the garage, so I'll run them in later. So I'll leave all the cameras and all these additional runs disconnected for now, and I'll put them in at a future point. But yeah, I've got all the Cat 6As in, and then also the 2 Cat 6 cables that go to the understairs cupboard. I've also managed to take off that phone point, put a dual network faceplate in, and terminate those here. So these go to the understairs cupboard, which allows me to bring the ONT through to here, and it also allows me to connect up anything else in the understairs cupboard, like maybe some energy monitoring type stuff. So yeah, what we now need to do is get these into the patch panels. But before that, I need to sort out all the bonding. This is like I mentioned in the previous video, where this Cat 6A cable is shielded. It's not got an overall outer shield, it's U/FTP cable. And what that means is that there's no outer foil shield, but each pair has its own foil shield around it to prevent crosstalk. And that's quite common with Cat 6A. You can get completely unshielded Cat 6A, but it's not as common, and it's very, very stiff with very, very tight twists in the wire. So this sort of U/FTP is kind of the standard type of Cat 6A you'll generally get. But because it's shielded, we need to bond the shield on this cable to ground. I explained more of this in my previous video, but what we essentially need to do is connect these to some shielded patch panels. Those shielded patch panels will then have a bonding conductor, a bit of wire coming off that then needs to connect to ground. So to do that, we have this big 16mm bonding conductor. There was a white paper I used to sort of understand how to do this. A sort of cabling company in the UK released a white paper based on UK standards on how you should generally bond this kind of infrastructure. So what I have is a 16mm bonding conductor that runs up through the bundle at the back there, through some steel conduit, and connects to the main earth terminal in my consumer unit. And what I'm then going to do is connect this bonding conductor here to a bus bar in the top of the rack, and then all the patch panels will connect onto that bus bar. So we'll do that first just to get that in, because I kind of want to get that up the top of the rack before I put anything else in, and then once that's in, we'll get the patch panels installed. Okay, so as you can see, we've installed the bus bar I was talking about. I showed this in the previous video. I bought this from a place in the UK called Comtech. I'll try and put a link in the description if I remember. Essentially, it's a 1U blanking plate, essentially, with a copper bus bar attached. It's got a bunch of screw terminals and a bunch of these sort of plates you can screw things under. So what we can do is we bring the bonding conductor into this bus bar and all the patch panels can connect onto this. If you're doing like a much larger install, say for example you've got a cabinet that is just full of patch panels all the way down, you would normally use a vertical bus bar that would run down the side of the rack and in anything in any U position could bond to it. But because I'm only going to have 3 patch panels at the top here, this smaller bus bar makes a lot more sense. What I've also done in advance of doing this is I've also moved these vertical rails of the rack back a bit. When I first got this rack, they came as standard right at the front, and I think I could probably cram everything in, but it was going to get a bit tight bending some of the cables around with the door in place. So I just moved these back a tiny little bit just to give enough space to move all the cables around. It also gives me a bit of space I can potentially sneak cables down the side. Obviously it's nicer to bring them through brush plates or whatever, but if I've say got a machine in the front here that just needs a single cable to plug into the front of it, having these moved back a bit means I can sort of kind of sneak a little cable around the back and not need to worry about brush plates, so that was worth doing there as well. So what we now need to do is connect the bonding conductor up to this. Now, in hindsight, you could probably actually just strip that back and kind of put it under one of these plates and kind of just stick it in that way. But I thought I would do it properly and I'll crimp a lug onto this so I can have a proper crimp lug to connect that up. So as you can see, I've already stripped back what should be the right amount of outer insulation for what I'm trying to do from that cable. And then to crimp it, I bought this very cheap sort of Amazon special crimp tool. Now, do not buy these sorts of things if you're crimping any kind of high current mains connections, because with that you want a very trustworthy tool that you know is going to do a good crimp. If you're doing any kind of mains connections, you're going to want to get a proper crimper from a reputable company, and yeah, you want something you can trust. This little cheap thing isn't great, but it'll do for this. So I'll put a link in the description if I remember. So it was one of those sets that I think £10-15, can't remember, it wasn't that expensive. You get both the crimp tool and a little box of all the crimp lugs. So it made sense to get all this as one sort of bundle because I'm only going to really be doing this once probably, so it made sense to get a cheaper tool. And it comes with a bunch of separate, differently sized crimp lugs. So what you need to do is select the one that's appropriately sized for the cable and with the appropriately sized hole in it for what you're trying to connect. Now this is where I got a bit confused, because if you look at these, they've got a sort of code on them that's like SC16-6. So the 6 on the end, sorry, this camera doesn't really focus very well, the 6 on the end defines the size of the hole in the middle, 6mm, and then I would say that the SC16 would mean this is for the 16 square millimeter cable, but this is a 16 square millimeter bonding conductor, and that crimp is far too big for the wire. It just literally slips off and you try and crimp it and it just falls off. It doesn't actually work. The 10mm one, or the SC10-6, fits this perfectly. So it does make me wonder, is my cable the right size or are the crimp lugs the right size? Like, I checked my order confirmation from Screwfix and it does say this is a 16mm wire I bought, but has something got a bit mixed up? And only I've lost the packaging for it, so no idea. I mean, even if it's 10mm, it's absolutely fine for a bonding conductor for what we're doing here, but yeah, I'll be using the SC10-6 just because that actually fits this properly. But yeah, it is interesting. I'll need to try and actually measure this and compare it to like a 16mm cable, check what size this cable actually is. But yeah, we'll take the SC10-6 crimp, put it on this, and we'll crimp it and, well, see if that works. Okay, so let's try and crimp this. So we've got the wire stripped back there to the right length, and then we're going to take the crimp. So this is the one that's got a 6mm hole in it because that's what roughly will fit best on that bus bar. And we'll put that over the end, and as you can see I've kind of stripped back just enough insulation so it'll sit nicely there. You won't see any exposed copper, not that it's really an issue for a bonding conductor, but it'll sit sort of nicely on like that. Then on the crimp tool, it's got this sort of little guide up here, and the way this works, I'll try and put that off to the side, and the crimp's fallen off. It's got this little sort of guide up here, and what you do is you open it up, and you can press these buttons in, and rotate this sort of die around to match whatever size of crimp you're doing. So because I'm doing 10 here, even though I think it's a 60mm cable, although it might be a 10mm cable, I'm going to put to 10 on both sides there, and that's going to be the right size for that crimp. And as you can see, it definitely isn't the best quality thing. It doesn't really align properly. It's a bit cheap, but it'll do the job for this one crimp. So yeah, I'll put a link in the description for this. Wouldn't necessarily recommend it, but hopefully it'll do the job. So yep, we now try and crimp this. So what I'm going to do is, just to make it a bit easier, I'm going to put the crimp lug inside the tool, just so I'm not holding a bunch of different things at once. It's one of those awkward things where if the cable was flat on the ground, it'd be much easier to try and crimp it, but I cut it a bit shorter just so I didn't have a complete amount of ridiculous excess in the rack, because you do kind of want to keep these bonding conductors as short as possible. There's a service loop outside the rack, of course. But yeah, so we kind of got that sort of in there, like that. What we're now going to do is take the cable, or take the wire, put that in the back there. This is probably going to be completely off camera. It's a bit low down, it'll do. And then we're going to try and crimp this. So try and crimp that lug down like that. There we go. Hopefully that is crimped. So take that off and let's see, is this actually attached correctly? So it's, yeah, that's actually crimped it. So yeah, weird that the 10mm crimp fits what's apparently a 16mm cable. Might not be a 16mm cable, I'll need to figure that out. Doesn't matter if it isn't though. But yep, that is now on there. So now we have a lug crimped onto the bonding conductor. So what we can now do is get this connected up to that bus bar and start installing everything else. And there we go, that's all now connected. I've also checked the measurements of this cable. It is definitely a 16mm cable, so don't know what that numbering means on the lugs. I'm sure someone will correct me in the comments. But yep, we've now got the 16mm bonding conductor, comes in, it loops around just to give me a bit of slack for future maintenance. I'll need to figure out a way to manage this and all the other cables in the rack. I'll probably need to put Velcro ties or something to try and hold them off the top of the rack, but it's sitting loose for now, but I'll figure that out later. So that goes onto the bus bar. And then just because I can really, it's not super essential, I've run another fly lead from the bus bar onto the rack. So on the top of the rack, you can maybe just about to see up there, there is a bonding lug. It's a little screw hole and it actually has an earth connection symbol next to it. So this is for bonding the rack. There's one at the top and one at the bottom of the rack, or two at the top, two at the bottom. So that fly lead goes onto there and then connects onto the bus bar. So that just means the rack is also bonded. It doesn't really need to be bonded, but if I'm going to all this effort to bond the patch panels, I may as well bond the rack as well. So yep, that is all the bonding in place. So now when I install the Cat6a patch panels, the fly lead for each of them can then connect up onto this bus bar to ensure all the patch panels are bonded, and therefore all the shields will be bonded on all the cables. So now it's time to install all the patch panels. So I showed these patch panels in my previous video. I'm using these XL Keystone patch panels, so they're designed for all the Keystone jacks. They don't have any kind of built-in terminals or anything. And these are really nice ones because they're designed for shielded cable, so they've got the sort of metal bit on the back of the Keystones connect to it with the fly lead. They've also got this really nice labelling window, so you can easily pop this off and put a bit of paper or a label in there, rather than sort of writing on or just having pre-labelled numbers. And they've also got this bar at the back for cable management, so you can tie all the cables to this to keep them secure. So I've already labelled all these patch panels up. I've used my Brother label printer, which I've made previous videos on, to print off these little labels for each labelling window. Just label all the ports down below. It's a lot neater than kind of handwriting them or something like that, or sticking a label along the front of it. And I've done what I've mentioned in my previous video, where rather than just making all the ports consecutive, I've kind of grouped them together based on what room they're in and spaced them out. Obviously in a more of a commercial setting, you're just going to run all the cables into the patch panel and label the port in each room with the number on the patch panel, maybe an identifier of which patch panel and which number port on that patch panel, maybe it's an identifier of which comms room it goes to. But in a domestic setting like this, I'd rather label them a bit clearer based on the room. For example, B201 is bedroom 2 port 1, LR01 is living room 01, ST01 is study 01, and so on. So what I've done is I've grouped them into, also using the kind of 6-port grouping this kind of already has. So these are living room ports, a couple of spaces. These are the kitchen diner ports, a couple of spaces, study ports, a few more spaces because I'm going to add more ports into the study, and stuff like that. What this also means is that if I ever wanted to add an additional port, say, into the living room, I've got spaces here to do that, and it means that numbering in the living room would be consecutive, because the next port in the living room will be LR05 rather than whatever the next number on the final patch panel would be. So that's kind of what I've done. So they're all labelled in there with a few different spaces. I'll put the ports into the appropriate spaces, and then I've got some blanks here that I'll use to fill in all the blanks. The last patch panel has only got, I think, 4 ports on it, but I'll be terminating CCTV into this in the future and various other things that will come onto this patch panel as well. So this will ultimately get populated a fair bit more. So yeah, I could have crammed all the ports I'm running onto 2 patch panels, but I'd rather space it out across 3 just to give a bit more spacing and also give a lot more room for future expansion. So yeah, time to get these patch panels installed. Okay, so now to terminate this patch panel, what I've done is I've mounted it lower down in the rack just so it's an easier height to work on. I'll get all the cables and get them all cable tied at the back and secured, and then we'll lift it up higher. And then from the bundle at the back, I've separated off all the cables that are going to need to go to this particular patch panel. And I've tried to sort of untangle them as best I could, so they're kind of separated from that main bundle right at the top there, rather than sort of having all the other cables tangled round and then losing a fair bit of length just because of that. I've kind of pulled them off so they're all kind of coming out that bundle right at the top there. I'll need to figure out a way to manage all the slack in the rack. That won't be fun, but we'll figure it out. So now we have all these cables here, so we can now just clip all these keystone jacks into this patch panel. And there we go, that's the patch panel all connected. So it's all the ports installed in the patch panel, filled all the other blanks in with the blanks, looks pretty neat. And the good thing with these blanks is they're actually really easy to take out. I bought some Connectix ones previously and used them, and they're really fiddly to take out. You had to use a screwdriver, whereas these you can very much do with just your fingers. So that'll be really good if I ever need to add any additional ports in the future. I can easily get the blanks out. So yeah, that's all installed there. As you can see down the back, all the cables are individually labelled, and then they're all tied onto this cable management bar at the back. So, you know, any sort of movement on these cables isn't going to transfer directly to the jacks. So that should be quite good. So what I need to do is try and manage this big bundle of slack somehow. Don't quite know how I'm going to do it. And then get this lifted up to a much higher position in the rack where it'll finally live. So I'm trying to kind of untangle these cables from the bundle at the back. Managed pretty well to get them kind of separate from the rest of them all the way up to the top. So what I'm going to try and do is bundle the cables for each patch panel separately from one another. So have separate bundles for each patch panel. I might ultimately tie those bundles together, but the idea being that if I ever need to service a particular patch panel, pull it out, change things, add additional ports, I only need to untie one bundle of cables just to get that single patch panel out. I'll be using Velcro cable ties for all that. It's going to be a little bit tricky just because these aren't all the same length. Most of them are roughly the same length, but some, like this link to the study, I don't know what I did when I measured these, but I've managed to cut them a fair bit shorter than the others. Don't quite know how I've done that, but anyway, so they're not all the exact same length. I mean, if you're doing this properly, you're more meant to kind of get all your slack kind of bundled up, then pass them through the patch panel, cut them all at the exact same length at the front of the patch panel, then terminate them. I didn't do that. I just kind of was rushing, got very bored of doing this, put all the jacks on, and then went to put them in the patch panel. So they're not all quite the same length, so it's not going to be an absolutely beautiful end result, but it'll be fine. So time to try and get this vaguely bundled up, get this patch panel moved up the rack, and then get the rest of them in. And with that, the patch panel is now installed. So that's now moved up to the correct position, and I've bonded it onto the bus bar with the fly lead, so that's now connected there as well. And yeah, that looks pretty neat. In terms of managing all the other cables and all the additional slack, it's not the neatest job in the world because, as I mentioned, they aren't all quite the same length. I've also never actually worked on patch panels in a full-size floor standing rack. Any floor racks I've worked on are like freestanding server racks that don't have really much structured cabling going into them. It's maybe a couple of runs going in. Whereas this is the first time I've worked with a sort of full freestanding rack with loads of space in the back that I'm terminating structured cabling into. So this might not be the best way to do it, and it'd be interesting to see if anyone has any helpful suggestions of better ways to do this. But all I've done is I've brought all the cables that are coming off the bar at the back that they're tied to into a Velcro zip tie, into another zip tie here that's just secured onto the rack here, and it kind of keeps this bundle of cables out of the way. And I'll do one of these per patch panel, so each patch panel has its own bundle of cables that comes off towards the back of the rack, where it'll then branch off and go into one big bundle that goes up through the top of the rack. There's also a fair bit of slack in here, but yeah, it gets a little bit tricky trying to manage the slack, especially with this cable this thick. If I move the rack further forward, for example, there'll be less slack in the rack and more slack in the bundle out the back, but then the rack will be further forward. It'll be fine. I'm not going for absolute beauty here, I'm just going for something that's practical, serviceable, and isn't kinking the cables too tightly or anything like that. So, yep, that's that one patch panel now installed. So now to get the rest of them installed, and then we can do more stuff. And there we go, that's all the patch panels now installed. So they're all installed there, cables are all managed up the back there. Not the easiest thing in the world, but they're completely out of the way, and they don't drop down below this U, so they won't sort of get in the way of anything else in the rack. So that's absolutely fine. So as you can see, I've put in all three patch panels, and I've spaced them out with one U in between. Now, when I finally set this up, people are going to get very upset because I'm not going to be putting switches in this space. The idea of kind of alternating switch, patch panel makes sense in very large commercial settings where you're mapping all your patch panel ports one-to-one into switches, and you want to be able to go away completely remotely and assign all the ports to different VLANs and never change all the cables. But that's not really appropriate for this setting here. Couple of reasons. First of all, not all of these ports are actually going to be patched into switches. Many of these ports are going to be used for HD-based video distribution and audio distribution, so those particular ports aren't going to connect into any switches, and instead they'll go through to the back of the rack and plug into an HD-based matrix switch and audio over Cat6 transceivers that will be installed elsewhere in the rack. On top of that, with the switches I currently have, I'm just using the existing switches I had in the flat, so they're not necessarily ideal for this setup here. I'm going to have 3 different switches, and each of them are different types of switches. One is just a 24-port gigabit switch for just assorted basic devices. One of them is a multi-gig PoE switch, that's up to 5 gig per port, and they're PoE. So that'll be used for things like access points and other PoE devices, or devices where I want 2.5 gig or 5 gig Ethernet. And then the third switch is a 10 gig base T switch that will be used for things that require 10 gig or for some of the servers that are in this rack. So even if it wasn't for running to other devices, if I was to put the switches in between the patch panels, it wouldn't really work because different ports will need to be plugged into different switches. So instead what I'll do is in these gaps here, I'll put cable management bars, put the switches lower down, and then I'll route the cables from the patch panels into there, neatly around the back of the rack, pop them out and into the switches. The cable management's going to need a bit tidying up. In this video, I'm just going to get something in and working, and then I'll work out a nicer way to tidy and manage all the cables. Likewise, I'm only using the old cables I had in the flat, so they're not necessarily the right length for this, so the cable management's going to be a future project, but yeah, that's the plan here, is going to be to put cable management bars in between each patch panel and put the switches lower down. But yeah, that's them all now installed, and they're also connected to the bonding up top. So now with that out of the way, the next thing I need to terminate is all of these speaker cables. So I showed this all in a previous video. This video is really meant to be part of that one, so I'm not really showing all the hardware in this. So if you want to see all the hardware I'm using, check out the previous video. But I'm going to be using the speakON patch panel. Previously when I showed this, it was a separate patch panel with separate speakON modules. So I've put all the modules into the patch panel, and I've also labelled them all up as to both what room they relate to and whether it's 2-channel or 1-channel, because these are 4-pole speakON, so they can carry stereo speakers, but then for some of the rooms they're just going to have mono speakers. So I've kind of labelled them up so I know what wiring to use with the speakON plugs. So for this, I want to put this right up at the top of the rack. Now, the reason I'm putting it so high up is just because I don't really need to service this very often, and I want to keep all the cables coming into the rack right up at the top. I don't want them sort of snaking around lower down in the rack. So I'm going to put the speakON patch panel right up the top here, put a brush plate below it to let me plug the speakON connectors in, and then bring the cables through the brush plate to the back of the rack. So yeah, that's all going to go there. On the back, each of these has 4 screw terminals. Normally the speakON connectors, you'll actually put a crimp lug on the cable and then plug the crimps on, but I got these screw connectors, they're just a little bit easier to work with, so that's what we'll be using. So what I need to do is get all those pink cables from there, poking out of this hole up here, and then get this patch panel terminated on. Annoyingly, I haven't left enough slack to actually get these cables down to a nice low level, so I'm going to have to do this entire termination standing up a ladder, which I'm not looking forward to. But yeah, time to get those cables in, get them into this patch panel, and that'll be the audio side of things done. So there we go, I've now taken all the cables, I've stripped them all back to about the same length, and I've relabeled them all just so it's a little bit neater than having sort of handwritten labels on them. So now to get all these installed into that patch panel. And there we go, that's the patch panel now installed, so all the speakers are now wired into that. Some of these are 4-core, some of these are 2-core, and then for the upstairs and downstairs landings, I've just wired them both in parallel into the same channel. So there'll be a speaker upstairs, speaker downstairs, but they'll both be mono speakers on the same channel, so they're wired in parallel there. So yep, that's all installed. The only other thing I've noticed is this speaker cable I've used has so much chalk in it, it's absolutely ridiculous. Like, you can maybe see it actually falling out, and the patch panel is absolutely covered. It's like it's snowing in here, and like down at the bottom of the rack it's absolutely covered as well. So I'm literally going to have to like vacuum in here just to clean all this chalk up. I mean, it's great because it strips really easily, but yeah, the absolute mess this cable makes is ridiculous. So yeah, that's that now installed, so let's get this up into the rack, and with that, all the cables will be terminated. And there we go, that's the speakON patch panel now installed. So you can see it up there, looks pretty neat. And then if you take a look around the back, you can see all the cable management, or whatever, if you can call this cable management, all the cables come in there. Speaker cables come in the left, and they sort of loop around onto the right with the slack. Velcro cable ties holding it all in, and then up into the patch panels. All the Cat6 and Cat6A cables come in the other way, break off into their individual bundles into more Velcro cable ties, and then run into their respective patch panels. So with this, I can fairly easily undo a single zip tie for each bundle and take out each patch panel individually to service them. So it's not pretty, but it works absolutely fine. And what's good here is none of this slack drops below where the patch panels are, so I could put equipment in even here, and this won't foul it, which is good. Then the additional spare Cat6 runs, so the ones for the light switches and a couple of camera runs, I've just left coiled up here for now, and eventually I'll run them into the patch panels when I actually finish off terminating those, so they're just going to sit there for now. But there we go, with the rack is now terminated. So with the rack all terminated, all I now need to do is get all the network equipment into the rack and get it all connected up and running. I'll go and do that off camera just because it's going to be a lot of moving stuff around, trying to figure out the cable management, and it's just going to take ages, so I'll do all that off camera and we'll come back. And then in the meantime, what we'll do is we'll jump up the attic quickly and take a look at what we're doing for the TV aerial distribution side of things. So we'll go away and do that, and we'll come back and take a look at the completed rack. Okay, so now before we go and set the rack up, let's take a look at what we're doing for TV aerial distribution, because I've got this almost ready. So when you last saw this, all there was up here was a big coil of coax cables just sitting disconnected, ready to be terminated. What I've now done is I've installed an aerial in the attic, so that's installed over there. It's pointing, I think, in the right direction. I'll need to maybe adjust it, but that should do. And as you can see, there's a coax coming off of that comes up into the cable basket and joins this big bundle here. Then for each of these coaxes, I've now terminated them. So you can see down the end here, they're all now terminated into F connectors. So I've used nice compression F connectors. My previous video, I show actually how I put these on. These are all now terminated and all labelled up as to where they go to. So now we can connect these up. Now, when you're distributing a TV signal to this many rooms, this is TV aerial, not cable TV. So if you're coming from the States where you're used to cable TV, it's not that, it's over the air through an aerial. With this many TVs, you don't want to just use some sort of passive splitter because you'll just get too much signal loss. You really need to use some sort of amplifier. So for that, we're going to be using this, which is a TV distribution amplifier. That's a particular model number there. There's loads of these on the market. And what this does is you can connect the aerial into the top and distribute out to 8 TVs on this one. There's different sizes you can get. This one, as you can see, it has 2 aerial inputs. It's got one for UHF and one for VHF. Basically, if it's TV distribution, you're going to use UHF, but the VHF one allows you to connect a separate aerial for radio reception, say DAB or just FM radio. That can plug into VHF. And then each of the filter faceplates you'd use on each of the ends of these coax runs, you'd use filter faceplates that split out into 2 separate connectors, one for TV, one for radio. For this, because all we're doing is TV, we're just going to connect the aerial straight to the UHF connection and just use straight connectors on the end of these. But it just has the radio option if you wanted. And then one thing you might notice with this distribution amplifier that you might not see with other ones is there's no power supply on this one. Most of these distribution amps will just have a sort of piece of mains flex sticking out of them that you plug in somewhere near the amplifier. But the downside of that is you then need to have a power supply next to the amplifier. You need to have a socket in the attic or something like that. So what's really nice with this one is instead of that, it has this external power feed unit. So it's almost like a PoE injector. You plug this into the wall. You then connect where it says amp. You connect that to the coax cable that comes up to the amp. It needs to plug into the port 1 here because that says 12 volts in. You then plug your TV out of that into here, and it just lets you feed power to the amplifier from a remote TV. So I could realistically hide this behind any TV, or in my case, I think I'll just put it in the rack because the rack's got coax run to it, so I'll put it in the rack and it'll be fed off of that circuit that's dedicated for sort of infrastructure purposes. And of course, if I did ever install a socket in the attic in the future and I decided actually no, I don't want this external power feed unit, I actually want it to be powered locally, there's absolutely nothing to stop me taking this power feed unit and put it in the attic directly next to the amplifier. That's completely fine. But just having this sort of split power supply just gives me that option to not have to put a socket up here straight away. So that should work quite well. So what I now need to do is just get this installed. So I'll just screw this roof truss there, something like that. Get all these coaxes plugged into it. And hopefully I've pointed that aerial correctly and we should be able to get TV reception. And there we go, that's the aerial lamp all installed and working. So you can see I've installed the aerial lamp there, got all the cables coming around into that, and I've left plenty slack, so if I ever need to like reconfigure this, replace the amp with one that's got the connectors in a different place, anything like that, there's plenty slack to work with. The only thing you might have noticed is that the aerial is no longer over there, and it's now all the way over here. Because I've had an absolute nightmare with this. It turns out that when it was over here, it was pointing at the main transmitter that generally serves this city, and I could get about 40 channels on it, that was it. It was just an extremely poor signal. So there was a lot of faff for me trying to try different transmitters, trying to get something. I was finally able to get a signal over here from a different transmitter that is significantly further away. It's all north of Dundee and I'm down in Edinburgh, so it's pretty far away, but I've actually got a very good signal on it. So it's very fiddly. Even moving that slightly higher up on that mast drops the signal completely. It really has to be very precisely positioned there. And in fact, I ended up actually setting up an old TV in the attic so I could wave the aerial around trying to get it positioned while watching the signal meter on this. But now it's finally positioned and it's very tightly, it's very, very particular, but I've got it positioned there. I've tightened it up massively, so hopefully it won't get bumped out of position. And with that there, I now get, you know, well over 150 servers. I basically get every service on that transmitter, so it works really well now, and it's just amazing how precise it has to be positioned. I don't know if it's potentially having to try and get around other houses on the street. I'm not quite sure how precise it is, but yeah, that was very, very fiddly to get working, but that's working up there now. So the aerial's in its new position there, cable runs up, over the roof, comes down here, comes down into the cable basket, and then comes out into the distribution amp. So yeah, that's TV service now working on all the TVs. So what we'll now do is we'll run back into the garage and finish getting the rack set up. And now we're back with the rack. So what I've now done is I've now installed some more equipment. So I've got all the switches in, so all these cable management bars. I've also put these brush plates in around the patch panels, and then another brush plate up here for the speakons. In particular, the speakon one I've gone for, it's not got a bottom on the brush plate, so I can easily take this out over existing cables without having to try and fit the connectors through this, because with the speakon connectors, they're quite big, so they probably wouldn't fit through a normal patch panel like this, or brush plate like this. So yeah, I've got the three brush plates in, and then the cable management bars. And then these cable management bars have sort of covers that can go over them to make them look a bit neater, so I'll do them once everything's up and running. But yep, so this is a very basic setup for now, just so I can get an internet connection back on, then I'll go through and start patching other things in and get the server in here and all that kind of stuff. But right now what we've got is the ONT in the understairs cupboard is patched into one of those ports, so it's patched into understairs 01. That then comes down into my firewall, which is my OpenSense box, so that plugs into the WAN port here. The LAN connection comes out this firewall over an SFP plus DAT cable into my multi-gig PoE switch. This kind of also acts as the core switch, so then the other 10 gig switch, which is 10 gig base T, and then the 24 port gigabit switch, all uplink to this single switch here over 10 gig SFP plus connections. So yeah, that's the setup there. What I need to do is power this all on for the first time, get some sort of basic internet connection back, and then we can get the rest of this all connected up. But yep, time to power this up. So if we go around the back, we can see the very temporary power setup I've got. Obviously, I've already got the existing socket in down here that we'll be using. In terms of a PDU, I need to get a better PDU than this. This is just my old 1U APC PDU for my rack in the flat, which was fine for that, but obviously it's not going to have enough outlets for the amount of equipment in here, and then a horizontal PDU isn't really ideal for a big, tall rack. So I need to get some sort of vertical PDU to go in here, but this will do for now. So for now, I've just got that plugged into the wall. The cable isn't even long enough to shut the back door, so I just need to leave the door open for now. It'll work fine. This is a very temporary solution. And then all the devices are just plugged into this over IEC to IEC cables that are incorrectly labelled because these are just whatever I pulled out the flat. So yeah, I need to get a better PDU and get more IEC cables in the right lengths and stuff, but this will do just to get everything basically powered on. So yeah, time to do the very first switch on and see if this all works. So that's on there. Got the power PDU. That'll take a little minute to start up. So once the PDU starts up and actually turns on all of its outlets, all this kit should then fire up. And there we go. So yep, that PDU does take a little while to turn all the outlets on. I think it's actually even phasing the outlets and turn them on in order. I can't remember quite how that's set up. But yep, everything is now booting up. So we've got the firewalls turned on, multi-gig switches booting up, but all the switches are booting up. So let's wait for all to start up, and then we'll hopefully have a working network. And with that, the rack's now up and running. So I've now got everything installed and up and running. I've also installed my NAS. I've got other servers to come as well. I'll be building a dedicated machine for running just home automation, so Home Assistant or all that kind of stuff. We'll have a dedicated machine, and I might put another VM host in as well. But for now, I've just installed my NAS because that was the most essential thing to get up and running. Switches are all powered up, so everything's now working. I've not patched in all the ports yet, but I've basically patched in both desks, a few ports in my studio, and just the ports that I absolutely need. Then for the access point, I've just set it up beside the living room TV for now, just to get the access point up and running. There's a lot more that needs patched in. Various TVs around the place, but equally the TVs aren't even installed on the walls yet, so they'll need some ports. When I install the additional access points, they'll need ports likewise for cameras, but this just gets the essential things up and running. Then in terms of cable management, what I've done is rather than labelling up each cable with exactly where it goes to or what it connects to, instead I've just numbered each end of the cables with the same number. So for example, I have this one here that's 004. We can then look down at the switches, find 004, and that's it there. Now, the reason I like to do this rather than labelling with exactly where it goes to is for patching things like this, cables are going to get swapped around, moved around all the time, taken out, chucked in bags and then repurposed. And if you start labelling cables with exactly what they go to, it can get very easily messed up where you move a cable to a different port, you don't change the label because the label printer isn't handy, and then you end up with out-of-date labeling. With this, all I do is I make sure that each cable is numbered. I've got a big bag of pre-numbered cables, so when I plug them in I can easily match up both ends. And this is also where we can see what I was talking about with my switches and why I didn't want to position them between the patch panels. Because as you can see here, we have 3 separate switches. Now, this switch setup isn't necessarily ideal, and if I was buying switches dedicated for this setup, I would have done it a bit differently. But I'm just using the same switches that I had in my flat, where I was previously split across 2 different racks, and the rack in my hall cupboard that was kind of the core of the network was a very small rack that couldn't fit large switches. So what I have are 3 separate switches, and each of these does separate things. The top, these are all from the Cisco Business 350 series, which I think they've just discontinued and then replaced with the Catalyst 1300 series, which basically looks identical to these, but anyway, these are from the Cisco Business range. And the top switch is a multi-gig PoE switch. So these 12 ports, it's a 16 port switch overall, but these 12 ports here are up to 5 gigabit and they're PoE. So they can do 1 gig, 2.5 gig, 5 gig, and obviously 100 meg as well. And they've got PoE across all the ports. I think some of them are PoE plus and some are standard PoE. Can't remember the exact specs of PoE, but this is the multi-gig PoE switch. So this switch will be used for devices that are either PoE or multi-gig. So if I have a device that needs 2.5 gig Ethernet, that'll be connected to this. If I have a PoE device, it's connected to this. And for things like access points that are PoE and 2.5 gig, they'll obviously connect to this. This switch is also acting kind of like the core switch, so the firewall connects into this, and then both other switches also connect up into this because it's got a bunch of 10 gig network interfaces here. So these are all 10 gig SFP plus connections. These are combo ports, these are either SFP plus or 10 gig base T, but yeah, that's what we have there, so this is kind of the core switch. Below that we then have a 10 gig switch, so the switch is 12 port 10 gig base T. So this is used for any 10 gig devices. Now, if I was doing this from scratch, for all the sort of 10 gig devices in the rack, I would probably uplink them over SFP plus directly into an SFP 10 gig switch. But when I was using this in my flat, I was using this with a lot more devices that were 10 gig base T, and then the link between this 10 gig switch and my core switch was also a 10 gig base T connection, so I've got a 10 gig base T switch, so that's what we're using. So this switch will be used for anything that's 10 gig, so for example my laptop docking station, anything in my studio, and also things like servers will plug into this. So my NAS down here is connected up to this switch over a 10 gig connection. The other thing to bear in mind with this switch is it's 10 gig, but it's not N base T. So it can do 100 meg, gigabit, and 10 gig, but it can't do 2.5 gig or 5 gig speeds, which is why I still need to use that switch here, this switch above, if I want to use any 2.5 gig devices. The final switch we have down here is just this much more basic one. So this is a 24 port gigabit switch, non-PoE, but it still uplinks over 10 gig. This switch will be used for most devices, so things like TVs, basic laptop docking stations or basic PCs that don't have 10 gig or multi-gig NICs, IoT devices, all that kind of stuff, management controllers, all the sorts of basic things are going to connect to this switch here. So it's not ideal having 3 separate switches, and in the future the dream would be to get one big switch. Say if I could get a switch that was 24 or 48 port with 10 gig ports and PoE all in one unit, that would be ideal. But right now, these are the switches I have, so that's what we're using. The final thing you might have noticed in this rack is all these blanks. Now, this is very much unnecessary. Obviously, if you're installing a rack in a data center where you've got hot and cold aisle containment, you do need to blank off the rack. This is a garage with basically no ventilation, so there is no real need to have any blanks in here, but I just think it looks quite nice. It makes a much more clean overall look when all the unused blanks are blanked off. And to do this, rather than just buying normal blanking plates and screwing them in, which are a complete pain to work with, I bought these things called Easy Blanks. I've seen these in use in data centers, they're quite common in there because they're very, very quick and, well, easy to use. So what these are, is they come pre-made in basically big 6U sheets. So they're just plastic, they come in 6U sheets, and they've just got these sort of push pins on the back to push them into the rack. So to take them out, all you do is just literally try and do it one-handed with the camera, which isn't ideal, but if I can say find a gap there, like that there, they will literally just pull out like that. They're very, very easy to pop in and out. And obviously they come in these 6U panels, but all you need to do to break them down in smaller sizes is literally just snap them. So they're absolutely brilliant for this. So it just means I can sort of blank off the unused U's just to get a better overall look, but they don't really get in the way or aren't really a hindrance to work with. Now, if you were looking to buy these Easy Blanks, you'll probably find that they're hideously expensive. I think to buy 10 of these 6U blank panels, so about 60 U's worth of blanks, it's about £140, which is a bit ludicrous for 10 bits of plastic. But I found someone selling these on eBay, brand new in box, for I think £30 or something I paid for this box, so that was cheap enough to be worth doing. So yeah, if you shop around on eBay, you'll sometimes find them a fair bit cheaper, so yeah, that's what I've gone for. And yeah, that's the end result. Very happy with it. Looks really good, and works absolutely brilliantly. And then round the back of the rack, it's basically the same thing you saw before, although we've now got a server in there, same PDU as before. I have now ordered a vertical rack PDU. It was meant to come today but hasn't turned up, so that won't be going in this video. If people are interested, I might do a dedicated video installing it, but equally it's just a PDU, so we'll see. What I might end up doing with a lot of this is I'll go away off camera, make a bunch of changes, tweak things, get lots of little things tidied up, and then just kind of do a generic update video every month or two just to kind of show how I'm getting on with projects. That might be a bit better, but yeah, eventually it'll be a dedicated PDU going in here. I'll also be adding in a UPS at some point as well, so that'll be going down the bottom. And then the other weird thing you'll see here is for the aerial amplifier, I needed that power injector, so I've just tied it up there, need to cut that cable tie off, tied it up there, and then because that has a normal 13 amp plug on it, I've just plugged it into this 13 amp socket to IEC adapter into this PDU. Longer term, I need to figure out what I want to do about things in the rack that need a normal 13 amp plug. Obviously with this I could just cut the plug off, put on an IEC connector and plug it straight into the PDU, or the new PDU that'll be going over here. But equally when I start installing a bunch of AV stuff in here, some of the multi-room audio stuff, I might be dealing with power bricks that'll just want to plug into a normal UK socket. Unlike in the US, where your sort of 1U or vertical PDUs generally have your regular wall outlets on them, in the UK, and I think most of Europe, they tend not to. You can get them, but generally if you're buying an APC or some other managed PDU, they use IEC connectors instead, which means that you can't just plug these sort of sockets in directly, these plugs in directly. For servers and stuff, it's not a big deal, because you just get IEC to IEC cables, but for things like this that you can't change the power, or especially ones that are like power bricks that you can't change the plug on, it's not ideal. So I'll probably see how I get on long term. What I might end up doing is I'll get the managed PDU on one side, and then might just get a basic vertical PDU with UK plugs on the other side. It wouldn't be managed, but then just for the occasional device like this, or various AV things, I can just plug them straight into that PDU. Or I just use a bunch of adapters like this. I'll figure that out as time goes on, but yeah, that's what we have here. And now back inside the house, here we have one of the finished network points. So I'm not going to show them all on camera, I've gone into detail in previous videos showing where I'm putting them all. But here we are in my office, and we've got this double network faceplate here. The cable on the left goes up to my desk, and this is a 10 gig connection to my laptop. And the cable on the right just goes to the device that I'm testing, and this is, I think, linked at 2.5 gig probably. But yep, that's all up and running. I've still got a bit of additional work to do to replace all these existing electrical accessories, because I've just got these white ones just now. I'm going to replace them with nice metal ones that'll nicely match the network faceplate. So I've still got to go and do that, so I'll do that whenever I get time, but don't know when that'll happen, hopefully soon. But yeah, that's when the network point's up and running. And then finally, just in case you don't believe me, that's the connection there, goes up to my laptop docking station here, where we've got my Thunderbolt 10 gig NIC, and that LED on the left being green indicates this is a 10 gig link. So yeah, it's working and sustaining a 10 gig link. So with that, I think that's all for this video. There's still a lot of bits to do, so for example, replacing electrical accessories, getting TVs on the wall, getting various other devices connected up and running, but I'm not going to do that in this video. What I think I'll do is I'll make a sort of, like I mentioned earlier, I'll make a sort of interim video where I kind of do like a little update, and I'll show kind of a little update once I've got stuff a bit more set up, once I've got some accessories replaced, TVs wall mounted, and more stuff up and running. So I'll kind of drop in and maybe do an update every month or every other month or something, just to kind of show what I'm getting up to. But yeah, that's when the network point's in the house, fully up and running. So there we go. That was me building my rack and getting my home network finally up and running. And I'm very happy it's finally working. This project has been an absolute epic. I definitely didn't bite off more than I could chew, because I definitely was able to do it all, as we can see. But I definitely underestimated how much time it would take and how much physical effort it would take. I am absolutely exhausted after doing all this. These videos are kind of been coming out roughly in the timeline it's taken me to do them. It's taken me weeks, or probably even a couple of months, to get all this done. It has been an absolute epic project, and there's still an absolute ton more to do. But seeing it all coming together and actually working is definitely giving me motivation to keep going with this, because this is so good to see it finally actually up and running. So yeah, that's the end of this 4-part series where I wire my house for home networking, whole home audio, and various other smart home services. Of course, there's a lot more stuff coming out soon. We're going to be building the Home Assistant server, building all the AV multi-room distribution, HDMI distribution, doing a ton of home automation stuff, smart heating. The list goes on. There are so many more videos due to come out. But finally, we now have an operational server rack, so I can start building everything on top of this. So yeah, hopefully you enjoyed this video, and in fact this series, and all that's left to say now is thank you very much for watching.